Yes, looking good.
Very good. Thank you so much. Very good. Well, thank you very much for inviting me and allowing to spend some time with some of the folks looking to achieve possibly the certificate in IoT. And as we head into this sort of topic, if I briefly introduce myself, I realized the bio you had, I've obviously got older since the bio was written, and I've realized that I've actually been working in technology for almost 25 years, just over 25 years now. So, and that's involved very much with startup technologies, new kind of technologies that emerge, and then we start to develop companies and typically sell them on. So there's been a few interesting adventures we've had, or certainly had over the last 20 years. Some of them here that have been quite exciting. The most recent has been a company called ThingStream that we sold to u-blox, the company I work with now. And u-blox is a very interesting, is a pioneer in technology to do with IoT, and many of the subjects we cover today are all connected really to those technology sets to do with connected devices that have to communicate with the cloud, and that's typically, you know, a common format of the technology use in IoT. So we'll come on to some of this as we go through this this presentation. So I took a look as well at the objectives behind the specific IoT certificate, and as the introduction said, IoT is such a broad subject. It's almost like saying the internet. You know, it can mean many, many things. It embraces so many different vertical markets, so many different technologies. You know, and so the subject I'm going to focus in on today is very much, you know, you'll get a flavor for the battery powered autonomous IoT, not necessarily the IoT which is connected to, you know, our watches and smartwatches and things like this. So less consumer and more on the business and industrial side. And hopefully the subjects we cover will be relevant to, you know, the key essence of the certificate of broadening your knowledge on this subject matter. So first and foremost, really, what's driving IoT? I think this is quite an interesting topic. We talked, and I'm very fortunate to talk to many, many different companies all around the world with so many different kind of ideas. They're either brand new startups or they're established businesses trying to do new things with connecting their products. But you generally find, or I certainly find, these subjects fall into three categories. The most popular is typically companies trying to reduce costs, and we can touch on a couple of those examples in a moment, but this is kind of one of those areas where most projects we get involved, I'd say 60% of projects that we get involved in, and I've experienced, have been around companies trying to optimize efficiencies and reducing their costs of things that they do. Then there's new revenue. Many startups and established companies are introducing new products that are sold, you know, as a service. So maybe the hardware, the things you use are given to you, like a mobile phone contract. You know, you get the free phone, but typically smartphones can be $500 to $1,000, but you have them free because you're signing up to a 24-month contract or something like this, where the value of the hardware, the capex, has been amortized across the contract. And that's very common now in many of the industrial approaches to IoT. So new revenue streams can be derived. And the final one is legislation, fundamentally keeping people out of going to jail, because there's lots of new legislations coming in where we need to know more things about objects we use and new areas of verticals where things have to be legislated, and we need to be sending the data about these things to the governments in the countries we work with, or the governing bodies of the particular markets we might operate. And again, we can look at some quick examples of that. So with the reducing costs, you know, very common things like, for consumers, you may have it in your respective country where you can get a cheaper car insurance if you permit your driving behavior to be sent to the insurer. So in that scenario, we're connecting the car and your driving capabilities of that car and sending the data, maybe not in real time, but regularly to the insurer. And they know where you are, what you're doing, and how fast you're driving. For young drivers, certainly where I am in the UK, it's really important. If the drivers demonstrate they're not driving after, I don't know, 9 p.m. at night, and they're not driving fast, then they get cheaper insurance quicker. So that's IoT in action, because the phrase is really just about connected things. And there we are. That's kind of a very common example we see growing rapidly around the world. And with supply chains as well, another common area. These are just a couple of examples. There are hundreds of examples. But again, with COVID, monitoring the temperature of the vaccines as they travel around the world. If they get too hot in transit, they get spoiled. So we need to either dispatch a new batch, or at least understand that the current ones aren't suited for any use. So again, this monitoring of things by sending the data into the cloud are common use cases for the Internet of Things, certainly in these industrial kind of applications. New revenues, very common, and again, you may have seen this, pet tracking, monitoring. I think this started really with dog owners. A number of companies around the world have established multi-million-dollar businesses by selling a dog collar or other types of, this has moved out into farming as well. But by monitoring animals, certainly pets, there's a high value there. People don't want to lose their pets, and many of them are curious about what their pets do, or if they take them for a walk or they get missing, they need a smartphone to quickly find the pet. And so therefore the smartphone needs to talk to the cloud, and the cloud needs to know where the pet is. And that's all about having some radio technologies connected somehow to the animal to get the data into the cloud. So again, there's a lot of moving parts in that solution, but when you look at the consumer packaging in the box, it looks really slick. And that's because the companies have solved all the complexities of making that possible. And that's another really popular IoT use case, as is predictive maintenance, where we have companies now, providing you extended warranties with inclusive kind of, gas monitoring systems for home gas appliances. And it's because they know the quality, they know what's happening inside of the gas appliance, because it's beaming its status all the time to the internet. And it could be monitoring systems set up on an application where alerts can be sent to both the consumer and to the providers to let people know when things are going wrong. So again, you might pay an extra few dollars a month for that service. So you've got continuity of usage of your gas. But that again extends to all utilities and many different services. And another really interesting area, which you may come across and may have seen already, is kind of, I think Accenture or someone coined the phrase X as a service, X being anything. And then you start to see companies such as Rolls-Royce providing their aircraft engines almost giving them away like a mobile phone, but charging for their usage based on the hours they fly. So now, because these engines can beam their continuous telematics data from wherever they are continually to the internet, an invoice can be cut every year or every month, or however the billing works, to charge for the usage. And there can be some other packages of support thrown in there as well. And there's many different areas of the world now moving to as a service models. But again, that's only possible once you've connected something to the cloud. And now the information is flowing from somewhere on the Earth's surface or in the skies into the cloud, where applications can be used to optimize and build applications. And then the legislative kind of play on this, there's a couple of very popular areas right now. Shared mobility, again, in your local cities, you might have shared bike schemes or shared e-scooter schemes. And again, certainly with the scooters and some of the bikes that are electric, in order for those operators to win licenses to provide the bike scheme, there is legislation coming, certainly across Europe and in the US, and quite possibly in Asia as well, where the operator has to guarantee that they know whether the scooters or the e-bikes are not on the pavement or the sidewalk, that they are absolutely operating in the correct part of the road. And so you need an IoT and some intelligence to guarantee that. So the system automatically brakes or stops the vehicle when it does go onto the sidewalk or isn't parked in the right area. So that again is all about connecting these devices to the cloud. Machinery operation, again, there's legislation coming in for healthcare, where if I'm providing an MRI scanner to a hospital, certainly again in Europe, these devices have to beam their status of operation. They have to prove they're fit for purpose to the appropriate industry bodies. And so again, someone visiting the hospital and physically inspecting these machines, wherever they may be, especially in the moving ones, they will be tricky to find. Again, it doesn't work. You have to connect these things, and they have to intelligently beam their capability to the cloud. So on and so forth. You can see this. And again, with prisoner tracking, that's been around for some time now. In fact, IoT is a phrase that's really, really sort of catching on, but things connected to the internet have probably been around for 15, 20 years as it is. It just costs more and was more difficult to do many years ago. So these are the types of, business drivers that are forcing the market to adopt and grow. So then if we start thinking about those use cases, we start to think about how do these things know, how does the e-scooter know to stop itself? Where's the computing done? How does that work? Or if a pet tracker is in now lost mode, the pet is lost or someone's stolen a bicycle. These are when the devices need to know that sensors have told them their status has changed and they need to do something. So that means you need some computing power on board the device. Depending on the complexities of your application, you're going to have different levels of compute power. The other point is where do you need your application to do the computing? And as per the bar at the bottom here, if you think about the individual device and we look at some use cases, well, a smartwatch, that's usually tethered to a mobile phone, and we're quite happy to charge our watch every day, every 2 days, depending on your make of watch, because it's useful for you. So the power isn't a big issue, and the watches do a fair bit of processing, especially the sports watches. Drones, again, consumer drones are different to industrial drones. We have customers who have autonomous drones that will inspect power lines, or they follow particular maps, to do inspections or videoing or surveillance. So again, the things they're often looking for are anomalies, and therefore the computing has to be done on them. They don't necessarily have time to send all that data back to the cloud. So again, you can imagine there's going to be some quite, heavy compute power going on, and therefore the components on board are going to be more expensive. The processors are going to be more expensive because the intelligence is the computing is being done on the edge. And similarly for vehicles, again, they have lots of power, so batteries aren't an issue here, but our cars we drive are supercomputers. They've got lots of different computers on them, all doing incredible and clever things. And as they move into becoming autonomous, they're just getting even more clever. So again, lots of computing power done on the vehicle, not in the cloud. And so these are just some examples of where, the different levels of computing that might happen. In other solutions, it might be that some of this data is sent to a network edge or a gateway, and they can do the processing. And if there's anomalies, then maybe send it to the cloud. Or alternatively, all the data could, for simple applications such as asset tracking, the asset doesn't need to do any computing really. It's just beaming its location, maybe its temperature, and a few other basic readings. And that can all just be sent to the cloud, and the cloud can compute whether there's something needed to be done. Has this asset tracker broke a geofence? If so, maybe wake it up some more. So there's these different types of areas in these different use cases and applications where the computing changes. And when it shifts, typically the device gets cheaper if you're doing more compute in the cloud. And if you're doing less compute in the cloud, you're generally getting a more expensive device and more expensive computational requirements because there's more intelligence occurring on the device. So there's this kind of shift you can imagine in these types of applications. And then we look at the power. So, on board the vehicle example we just had, well, in the insurance use case, many of you may be familiar with these OBD dongles, and there's other ways of connecting to power on a vehicle. So we've seen the phrase telematics, I think, has been around before IoT. And so many devices have been connected to the internet before, some even using satellite bandwidth, so really expensive. But for agriculture in the middle of the countryside, this has been affordable. And so the power is really important. But what we see is a gradual shift now to more and more devices where people won't get involved. They are sold or they're provided to a farmer, and they're dispatched, and no one will ever see the device again. They're almost disposable, but they have to last 5, 10, 15 years. So no one's going to recharge them, and they typically have to survive on battery power. And that's a really interesting concept, because we work today with hundreds of companies that are all wrestling with, how do we maximize power on board? How can I have the smallest possible battery, but the longest lifespan for my device, so I can make it cost optimized, but also reliable for the use case? And it's typically lithium batteries, not exclusively, but we typically see it's lithium that's driving this area. And obviously with us, all the electric cars coming through, lithium and copper and cobalt, all these natural resources are the things needed for these batteries. So they're kind of going to go up in price. They're going up in value because there's a limited supply of these raw materials in the world, and we can only extract so much at a particular pace to build these cells, the different chemistry mixes for our different batteries. So that becomes a bit of a challenge for IoT. How can we limit the usage of these natural resources, which is good for sustainability, whilst maximizing our kind of ability to make a profit? So that's kind of the paradox, or the balancing act that is required. And this is just a screenshot from a quick search for lithium battery growth on Google. And you can see all charts just show your classic hockey stick growing, and it's double-digit, compound growth year on year. The demand's just continuing to increase. And as I say, it's the electric vehicle market that's probably driving a lot of this, and will probably win the lion's share of the supply. Therefore, when it comes to improving efficiencies of our everyday lives and all the other good IoT use cases, then we have to be mindful that the battery, the power, is a really important factor here. You may, as part of your certification, and if you're studying the IoT side of things, I don't know how deep you go into looking at this kind of area, but there's lots of, if you like, new energy coming through, new energy sources, energy harvesting technologies, so we don't have to rely necessarily on the battery, which is great. Typically on screen, you can see this is just a standard USB power bank, but it comes now with a photovoltaic cell on the top to provide some extra top-up charging. So this is being adopted. We see lots of maybe agricultural IoT, which might come with a smaller battery, knowing that it's got line of sight to light, and it can power itself to a degree, or at least recharge itself satisfactorily over the course of a day. But there's lots of other energies coming, movement-based energies and whatnot, all being shrunk down now into microchips and small sensors or components in different shapes and forms to assist with the continuous powering of the battery cell. And it's typically, you do need a battery cell in order to be able to fire up a radio to talk to the internet fundamentally, and obviously also process the computer on board the device. So as these things get low power, or they need and require, as technology improves, the battery's power is needed less, but it takes years and years for this to improve. So we have tens of thousands of use cases today where we need to be mindful of the battery usage right now. So typically, the manufacturers of such devices will be looking at where you can optimize power. And typically, you find that a design engineer will be looking at using, ultra low power microcomputers on board. So really low power MCUs that are really simple, and they don't need to be computing heavily, as per some of the use cases we touched on a little earlier. You'll have also may have come across these concepts of low power radio, and we'll come on to this. But again, there's the mobile phone networks around the world have deployed radio technology, cellular radio technologies that need less power for the radios to operate. So again, that's helping with the overall requirements here. Oddly, and something I've learned over the past few years, is the importance of placing antennas at the right places on board the PCBs that go inside of the objects and the products that we're making. And again, there's specialists in the market who all these companies do is provide, testing and the best support to put the antennas in the best place part of a device, be it on the PCB, because it's has to be. So for example, my watch here has an antenna sort of printed on it inside. Others could be tracking devices where the antennas have to be external. So again, all these different use cases, depending on where these devices are based, or dictate some of the physics around the antenna. So that's a really important area to be focusing on. And it can sometimes cost, significant money to get that right. But once you've got it right, it can save, a lot of money going forwards with your products. And then the coding, obviously then writing code that's super optimized and it's very smart in the way it works. Some badly written code could run very lazily on board the computer. Therefore, it just makes everything run slower. So like any regular, application that you could write for a computer, nothing changes. It's the same. If you can optimize your code so it's really efficient in the way it operates, that again can reduce your drain on battery. But oddly, and this is not known to many people, and this is kind of interesting, it's often the language that your device communicates. So if you can imagine IoT, you've got all these different devices and they all connect using different radio technologies to the cellular networks or to your Wi-Fi network or Bluetooth. And when they connect, they're having a conversation with something. Typically, a connected scooter would communicate. It would make a radio connection over the cellular networks to the cloud, to the internet. And then it will establish a secure connection so it can safely send its data and receive data. And then it will share, the various different current statistical information it has to send for the application. And all of that can take time. And so depending on your language, the different types of protocols, if you will, and that's what I mean by language, that can be used radically differ in the amount of characters required and the way they work to communicate with the cloud. And so on screen here, I'm just explaining, if you like, at one end of the spectrum, you've got the, the age-old HTTPS, which our internet browsers are using. Some companies will always, for whatever reason, implement HTTPS on their devices. And if it's battery powered, the S is security or secured. And if it's battery powered, this means the payload is going to be really big. The length of time to establish a conversation, it's a lengthy period of time, could be minutes. At the other end of the spectrum, there's other protocols such as MQTT-SN, which are designed specifically for kind of sensor-based applications where they don't even need to establish a conversation. They would just connect to the radio network, send their payload and turn off because they operate differently. And so you could have the most optimized design. You could have the most low-powered components and the best code in the world, the antenna perfectly placed in the right area. But if the device then decides, or the designer is going to decide to use the communications protocols to be one of these sluggish kind of legacy protocols, all of the benefit of the design has been lost because you're not continuing the same development cycle by using, a thin and agile protocol such as SN. So for those of you who may or may not know, the MQTT it's a open standard for communication. There's the MQTT org, of which u-blox is a member. And interestingly, there's a sub-specification, or one of the specifications you can see here, the one at the bottom here, which is SN. And this is specifically designed for IoT. It's designed for sensor networks. It's designed for things to quickly get their data into the cloud and then power down to preserve battery. So I don't propose to go into the technical side of that right now, but it's a really important takeaway. It's the language used by the device to talk to the cloud can be super important in order to have a smaller battery or have a lifespan much, much longer, 3, 4, 5 times longer by using these neat protocols that are more efficient in the way they communicate key information to the cloud. So again, I can share more information for those of you who are interested, afterwards, if needed. So if we then take that kind of information as a backdrop and we think about some of these common use cases. So I'm just going to dive into 3 to put some kind of, context into what we're talking about here. So we've taken, 3 common use cases. The frequency that these devices have to communicate with the internet or the cloud, are kind of shown on the timeline here. So a pet tracker, well, when it's active, you know, I've taken my dog for a walk, it might want to ping once every 5 minutes, once every minute. If the dog's lost, or I press the thing on my smartphone to say I've lost my dog, it will send a signal to it, maybe to wake it up every 30 seconds. So that's quite a frequent use case. But similarly to my smartphone or my smartwatch, a pet tracker, I'd probably charge that once a week. So the batteries on these designs have been carefully, in this particular design, have been specifically made for fitting around that strap, and everything's been super optimized for power. But again, the usage of that would be maybe a weekly recharge requirement. Then in the middle, we have the likes of cargo tracking, where they're not rechargeable. Typically, cargo tracking or supply chain tracking, these types of applications, people would want these to last for 5 to 10 years. So that typical box would just be subtly applied to a vehicle or a reefer or something on the back of a truck, and that's it. It would never be touched again. And therefore, they need to live a long time, and they might be pinging a message every hour or every day. And again, so they won't be, so the battery has to be quite a sizable battery now to meet this kind of 5-year requirement, which is typically the average. Some are less, some are a lot more, depending on the use case. And then in other areas are things like condition alarms, where, as you can see here, we have a solar panel on this. So it might have a battery to hold the residual charge, but there's always a trickle charge happening through another source effectively. But again, this could be then put in the middle of a field and forgotten about. It just magically sends all of its sensor data. Maybe it's a moisture probe or soil sensor. It just sends its data, continually into the cloud, and pretty much looks after itself for many years as well. So these are just 3. There are many different variations on this, but they kind of give you an idea of what we're talking about. So that's kind of their message frequency. And again, the corresponding year, this pet tracker, well, that's rechargeable. That's fine. We can recharge that once a week. And at the other end, you have things that just, will never be recharged. So again, interesting concepts when you're thinking about IoT is the underlying power requirements here. And as I said before, the protocols that you may come across, like MQTT, HTTP is probably the heaviest protocol by far. If you need to secure this, it will take up huge amounts of data and lots of battery time, because it has to be on air on the radio network for a lot longer having a conversation. Whereas I say the SN protocol is much faster. And so you get these really big discrepancies in the usage, the drain on the power. And that's typically as I say, you've got more time on air to establish the connection, to establish the security of the connection, then to start sharing your payload and the conversation you have around what data I'm sending to the cloud and if it needs to send anything back. And again, the sizes of these payloads can be significant. And in my 2 small people icons here, that's a big difference. You could say the send for a track and trace application, sending exactly the same information to the cloud would probably take 6-7 kilobytes using secured MQTT, even more, 15 kilobytes maybe with HTTPS, much bigger, whereas it could be just 50 bytes depending on how you're using MQTT-SN. And again, this is often when you're talking to a startup, they've got an amazing device, and it does an amazing thing, and they've built the prototype, but they haven't really thought about the costs of operating 10,000 of them. And so I guess this talk is about sharing the knowledge, because this is what we're doing. We're educating, companies and individuals about these things that could seriously impact the operational cost of a business model. And it might not stack up. People might go, it's too expensive. The cellular data I need to use for my application, I can't charge that onto my customer. My business case doesn't work. But in actual fact, it could. They just haven't yet discovered maybe all of the features or the specific technologies that are available to them to make it happen. And again, depending on your level of knowledge and how far you want to look into IoT, if you start looking at cellular-based IoT, then there's a huge range of different, cellular modules that can be used. And I guess the takeaway from this slide is really, globally around the world, wherever you're based, I'm pretty sure you'll more than likely have a 2G network still live. Even in the US, there's still a 2G network. I think it gets sunset next December. And LTE, regular LTE, 4G that we see on our cell phones, that's ubiquitous. You know, in pretty much all countries around the world, you'll find that as well. But when we start looking at the low power options, they're not ubiquitous. So again, the point being is we often talk to customers and we explain to them that why not choose a cellular module that will work anywhere in the world? And on paper, it looks like it's going to use far more power than the low power modem, cellular modem option. But when you look at where the cellular operators are, or where you can use the low power modems, NB-IoT is something you might hear about, LTE-M, they're not ubiquitous. But as a manufacturer of a product, I want to sell anywhere in the world. I don't want to limit my business. So when companies discover they can use the modems that give them global coverage, but cost less power because they're using a different protocol, it opens up whole new business models. And that's kind of really interesting to take on board, depending on, you know, what you do with IoT. So the second kind of part of the talk today is just look at some use cases and show you some of what I've told you sort of put into action. So again, looking at cargo tracking, if you take a kind of typical use case, you know, we have our shipping containers on the back of ships traveling all around the world, and they hit the roads on the back of trucks. People want to track where they are. They want to know that, you know, this just-in-time shipping, you know, approach, this kind of Amazon-esque delivery network is required. People need to know, where is that ship? Where is my cargo on board that ship? When will it arrive? So it's really important for, you know, just-in-time delivery, making sure people are available to unload, all these types of things. So here we have those trackers I mentioned. They need 5 to 10 year lifespan, pinging daily or every other day, or maybe every 6 hours. It depends on the use case there. But typically, to make that business model stack up, they need to be around. The whole product, the CapEx for the product, should be somewhere between $50 and $100, depending on the complexity of the device and what it's doing. Refrigerated monitoring trackers are more expensive, but just a regular dry cargo tracker you should be shooting for around $50 to $60, I'd imagine, depending on the scale. But again, customers need, you know, they need to know as well the predictable cost of this stuff. And the trackers probably need to receive information from the cloud if they need to have a firmware upgrade, or something might be required to change on board the computer on board. So, you know, that's what I mean by when we put bidirectional comms on here. So that's kind of what we're after, something that's going to last for that period of time and provides a simple, you know, GPS position, typically, you know, to the cloud. Often these customers also need to ensure that data, you know, you might have someone building the device, or the customer might buy a device off the shelf, but in the IoT application in the cloud, they've used one of these popular application environments to build an application that's monitoring, that's mapping, that's alerting. All those types of things are required for an application. So again, the customer needs to make sure that's seamlessly integrated as well. And this is all part, I guess, of what u-blox provides, but it's interesting just to put that across to your understanding. You know, there's more than just the tracker in an application. It's then how do you connect it to the cloud? How do you integrate and provide all of that? And then who builds the application and what does it do? So these are the requirements of these typical applications. And when you start looking then at what do you use? What radio do you use to connect that thing from wherever it is in the world, or Asia, or wherever it might operate as a business, you know, as where the businesses operate their tracking requirements, then you probably will come across in your learnings of these three popular types of low power, wide area connectivity types. So you typically may have heard of Sigfox. That has been growing. I think it's kind of slowing now, and there's maybe some changes in the way the business is going to operate, but fundamentally it's really low power network that's usually typically geographically available. So in Europe and a few countries here, there is a specific Sigfox, a network operator. There may be some, there are some in Asia as well. At the moment, they're not super interoperable. I can't necessarily bring my devices I use here on Sigfox and bring them to Asia and drop them into, you know, KLCC in Malaysia. that won't work, because of the different radio types and what have you. More popular is LoRaWAN, which is more around municipalities. So cities might have a public LoRaWAN network. Some countries have public LoRaWAN networks, such as KPN operate this in the Netherlands. I think Orange in France have a LoRaWAN network that runs alongside their cellular network. And again, it's really low power. So these are good radio networks for domestic applications where you just need something static typically, and it just needs to efficiently get its data into the cloud. And the cellular version, as I said, you'll hear of this NB-IoT, which is more popular, I think you'll find in Asia. In the US, it's an LTE-M market. There's not really NB-IoT commercially available there. And in Europe, we've got a mix of both going on. So again, there's different options depending on your use case. In the sort of a global asset tracking scenario, you typically wouldn't want to use Sigfox because your device would only work in certain countries, depending on which type of the Sigfox devices you've used. And again, it's not prolific across all countries. LoRaWAN, that's tricky because again, it's more of a domestic offering. You wouldn't typically have a truly global LoRaWAN offering because the networks aren't ubiquitous. So cellular really is covering the world. Obviously, there's satellite as well, but that becomes a very expensive, and high power use case. Though there are low power satellite developments coming, but they're not here yet with the lower Earth orbit options. But cellular and the low power, it seems pretty good. It would give you in theory, it would give you the ubiquity you need for your solution. But we need to check coverage. Will I be able to get LTE-M across all of the countries that I need to track my cargo or my goods? So there needs to be a bit of a mapping exercise that you need to do. Oddly though, in this scenario, if you look at 2G or even LTE-M, it's global. So if you knew you could use those networks in an extraordinarily low power format, you still achieve the same goal. The modems might cost a little more than the low power modems, but when you understand that means you can operate your business anywhere, sell to any customers, I think the opportunity is obvious. It's a small upfront cost for the trackers to be able to work anywhere in the world, rather than limit them to specific geographies, etc. So again, when you combine that with the maybe 2G and LTE, and you can get these modems, even our company, we sell them. They will have LTE-M technology, the low power, combined with 2G to allow for where there might be lacking networks in terms of LTE-M. So it can toggle between the two networks. So there's really interesting solutions where you can get the best out of the cellular networks available, and again, have extremely low power for, and therefore don't use either as large batteries, or you could have smaller batteries for your specific use case. The pet tracking scenario, again, I take just a real world example, similar thing. These need to be, again, we're recharging the device on a sort of weekly basis, so the batteries are less of a worry, but more about if this company, in this instance, Portrack, want to sell their products anywhere in the world, then again, it's IoT, it's a connected device, it needs to communicate with the cloud. The cellular networks are going to be the best options again, just because they have the reach. And again, you can see here the common theme is, why not use a modem that has LTE-M capability, so low power in those countries where there is low power networks available. But it doesn't matter, even if it has to hop onto the 2G network as a fallback, it's still going to use extraordinarily low power anyway. So again, you see the theme here. Things aren't always what they seem, and these solutions that we build have to be mindful of where do we do business, and then we have to find these intelligent solutions that fit the application requirement, depending on what we need to put together here. And finally, community safety example, a customer we work with in South Africa and beyond. And again, they have these battery powered gateways that talk to lots of other smoke alarms effectively. And so it's a fire detection network talking to a gateway. And this company will provide these to anywhere in the world. So again, they need to know they can confidently sell their system, knowing it will just work, because on board, they've built in for the options of it can pop up anywhere and use any type of cellular. And we think that's a really important factor when we talk to customers looking for, growing international businesses effectively. So a similar story there, where again, Sigfox and LoRaWAN are perfect for domestic or geographically constrained use cases, but from the global perspective, then you again head towards the cellular networks, because they provide you the coverage that's required to confidently do business anywhere. So I thought that was just interesting to share with you, those thoughts on, there are a lot of things that are draining or will demand battery power, and often it's just the protocols that these things, the devices communicate, the language they use, can be the biggest factor in preserving the battery power and helping to underpin, a sustainability story for a particular, company. So I think that's interesting. So that comes really to the end of this particular subject. I'm fascinated to know if anyone's got any questions.